Hey folks, thanks for joining this front bag. Score the Tendulkar test coverage, and we have one Sachin also on the call. So the reason why I named this brown bag as Tendulkar, Sachin Tendulkar is like he's famous for his dismissals at 90s. He even holds a record. He was dismissed 28 times while he was in 90s. So think about it. If they have converted into centuries as well, like he would be unbeatable today. And whenever I see coverages like this, I think of the Sachin's quotes. I used to be equally nervous, and I think it's who were born in 90s can relate to this. So this is a coverage numbers that we were able to achieve in billing schedule and back in 2, 3, 4 last year. And before this, it had zero unit test coverage. And there are certain methods that we follow while refactoring this, and then we were able to achieve a coverage at this scale. And we feel this can be done for a lot of modules that we currently have. And this is, again, we haven't had to really go extreme to achieve this. It's very simple principles that we followed, which I'm going to discuss today. And also this, I want this to be an interactive section, and I want to learn more challenges apart from the ones that I am speaking. Whatever I'm discussing today are contextual to what I learned over the years working on code, and of course discussing with different engineers and different Scrum teams as well. But yeah, please pitch in. You can, even if you have doubts, you can interrupt me in the middle and ask, or even after the brown bag, we can discuss if you have more challenges, or if you see something that whatever that we discussed in this talk is not exactly as possible to be implemented. We can see the challenges and see how we can take it forward. And starting with why unit test at all. So of course, unit tests are not to find bugs. Of course, we should rely on QA testing properly. Unit testing is all about behavior documentation in the form of code. So you have a component, and of course, you might not be the one who will maintain. And a lot of people in our shared code base, we work together, and things keep getting enhanced, changed, and there should be a way, something that should fail if there is a change in behavior, and that's what unit test does. And sometimes you might feel there is a simple method. Why do I even have to write test? Test is not about to verify or find bugs. It's just that you're saying, okay, this is how it works, and I've left the code. Okay, I've even left the company, and somebody else came in. If he changes, it should break, and it should assert that, okay, you have broken some behavior or diverted from how it used to work. And always strive for behavior coverage, not statement coverage. Unfortunately, the tools we have don't measure this behavior coverage. They show you statement coverage, and there are n number of ways to achieve statement coverage, but behavior coverage is what we should focus on. But in the end, it's not as easy. I mean, it's good, it's glossy, but then why is it so difficult to achieve? One of the reasons, like we see a lot of code smells in the code, like void methods, especially make it difficult to unit test because they don't return you anything to assert. And static methods, which exactly are not static, but they're doing something else, doing everything in the world. And bad design, especially like when you're directly interacting with legacy code without declaring your dependencies. And of course, legacy code interactions, which is prevalent in our core code, a lot of legacy classes that we need to work on. But tell you what, if all we want is statement coverage, we have the hammer, our age-old good friend PowerMock sledgehammer. And let's check out what all you can do with an example. This example is something I have even presented in a hackathon demo. I just wanted to go in depth, in detail a bit, because in hackathon I didn't get a lot of time. So take, for example, tags, and this is something I wrote for the hackathon demo, although it is inspired from what I see on a day-to-day code base. Take, for example, simple Pojo, stacks details response. This is a Pojo, you don't have to know what exactly is stacks details response. And it has some details, and you want to put that in an entity invoice line object, which is, of course, a standard entity data template object. And this is how the code, to test this code, you have to do a lot of things, especially you need to start with, of course, preparing this for test and mocking all the stuff, and then a lot of when-then statements. And then especially you see this here, right? What you're trying to do is, when I'm asking for a new invoice line object, return me a mock tax line. Let me also put the prod code side by side. So I'm trying to mock this statement asking if when I call this new, I want a mock invoice line object. And I'm also setting some expectations when I call this, return this, etc. And then what happens is I go here and I'm asserting whatever I have set here. And this happily, silently passes. And let me tell you, if I run this with coverage, it gives me 100% test coverage. So that is the disadvantage of statement coverage, statement-based coverage, wherein if you just rely on that, you can achieve it. But there are many ways, there are even libraries I know that just putting the library and giving a class, it will do some magic, dark magic, and will give you 100% test coverage. I know in certain companies where that's like stress on code coverage, people even follow that. So in the end, gives you a lot of power. It lets you suppress this and super constructors, static init blocks, and even it lets you stub private methods, static methods, final methods, constructors, mock final classes. What else? What not? It's like you are unstoppable, right? You should feel like this. You should achieve 100% test coverage. Like you have your hammer in your hand, nobody else can stop you. You call the power mock Rocky. But the dark powers are also like they come with a lot of, as we see in movies, these dark powers come with a lot of disadvantages at the same time. So synthetic coverage, of course, is dangerous. It's better than not. It's worse than not having coverage. At least you know that it's not covered. But knowing that it's covered and relying on such a test obviously will bite you. And PowerMock is, of course, when you talk about learning curve, when I had to start, like I got to learn about PowerMock only here. And then I really used to feel good when I used to Google, find a lot of tips and tricks and ways to bend test code. In my initial days, I thought I was a pro, but even today I'm not. Even today I have to do a lot of, set up trial and error. I sometimes miss some sort of mock static or something, and I keep thinking what happened. And I relate that to a lot of friends who used to ask me like, "Hey, this is not working," and then I, from my experience, I could say something like this, and that was so silly, and it's not worth our time as well. And when it comes to learning curve, PowerMock is extremely difficult. And tests written with PowerMock are so brittle, and we're going to discuss more about this going forward. But a simple, even single line of change would in production code would need you to update a lot of tests, and they're very difficult to maintain at the same time. And it's not transparent. As I mentioned, if a test fails or succeeds, you need to really go debug. And the framework itself is not transparent in giving you explicit feedback on what is wrong. And this is how it feels with refactoring with PowerMock unit tests, where you keep getting requirements, your manager keeps pushing for your test coverage goals. And that's a joke, by the way. Manager holding their whip. And PMQ3 are also trying to give you more requirements, asking you to extend code. But your PowerMock unit tests are like your food chain. They're not aiding you. Tests should aid you to refactor, but in turn, tests written with invasive tools like this, they actually pull you back from extending your code or enhancing your code. So in the end, I would say PowerMock is a painkiller. It doesn't treat the actual ailment in code or design problem in the code, but it lets you achieve coverage like a painkiller, what we know. So why is PowerMock invasive? Okay, Gopal is saying a lot of things against PowerMock, but I see every module in core uses it. It's very popular, invasive. It spreads across. Why is that? I was even curious. I wanted to actually see what is PowerMock, and I went to the website. This is what I could find on PowerMock. This is the powermock.github.io, the official website of PowerMock. And their sales pitch is, I highlighted a few things, but you should really read all of this paragraph. And something that says, when writing tests, it's often useful to bypass encapsulation. I would say that's something like a robber barging into your house. See, and the irony here is, you have the keys, but you're barging into your own house. You're breaking into your own house through a window. Right? Breaking encapsulation is the first top rule that you're taught in college, that encapsulation exists for a reason, that you shouldn't break. It's a capsule, and you should test externally. Test should be like a client. We'll discuss more about it. And you should even read the other lines as well. Like, therefore, PowerMock includes several features that simplify specifically for use for testing. And there is one more line here. I didn't highlight, but you should really, this is interesting thing. And this is one more, please note, POMOC is mainly intended for people with expert knowledge. Why is that? It's like you don't put gun into a toddler, right? You don't give a gun to a toddler. The reason is it's dangerous. They're saying it in a nicer way. So the moment you give it to somebody who doesn't know how to use it, he would of course use it in a way to sort of not write tests like this, which would generate coverage but hide the actual ailment and don't even test the right thing. And if you even go to check the PowerMock website, it's not well maintained. You should actually go to the GitHub. You can see a lot of issues, and on top of that, it's not compatible with JUnit 5. If you know, JUnit 5 is released 5 years ago. They even have a pull request to support JUnit 5, which has been pending from 2018. Nobody is looking at it, and should just check at the issue count they have got in PowerMock. It's not actively maintained, by the way. And a lot of blog posts, of course, which don't support PowerMock, which talk against their organizations which blog PowerMock, and it's even incompatible with Mockito 4. PowerMock is something like a wrapper over Mockito. Mockito does everything like it doesn't have anything hidden, doesn't do any dark magic. PowerMock is on top of it. It's like a wrapper which does all of it. And today the trending PowerMock is 4.2, and Mockito is 4.2. PowerMock doesn't support more than 3.12. And the irony is Salesforce has their own PowerMock shade jar. Like they have their own publication of the jar, and that works only with Mockito 2.0. We are so very like in 2015 or so, this was released, and this is. The unit testing has gone ahead, and even we should see Mockito 4.2 has so many nice things, so many nice features that we should explore, which we are all missing out because we are stuck with this PowerMock, which is an old jar. Yeah, this is where I just want to address. So why do I need unit tests if I really had to go through all this, and in the end I get a coverage which I can't rely on? Can't I just rely on F tests and get coverage? So I just want to have a very short brief thing about F test versus unit test. What should do what? So this is one of my favorite diagrams from this great book, which I read as a fresher, and I highly recommend a lot of people to read this. Like especially as newcomers, it's like it speaks about a lot of stuff that we do here. So this use case diagram speaks about. Imagine you're building software for a subway line company or some like metro, Hyderabad metro thing. So you have two personas, administrator and travel agent, and there are two use cases. So use cases speak about how a customer uses your application. There is a load network of subway lines is the use case, and that would need two features, which is represent subway lines and the stations along each line, and load multiple subway lines into the program. So admin is supposed to load that data into the software, and then the travel agent is supposed to find the route, and the get directions is a use case, and figure out valid route is a feature where he would get directions, and print directions is a feature. So use case is how customer uses your software, and feature is what reflects the functionality, right? So if you see the relationship, use case will have n features, and a feature has n components. N components make up a feature. So F test should actually test features. So when you see your F test suite, you should be able to figure out what features does that particular module supports. So and nothing more, nothing less. And unit tests, on the other hand, should test component behavior. So what happens generally is because of the hassle that we have, challenges we have for writing unit tests, we are using F tests like unit tests where we just change one parameter and then sort of, let us say you have a REST API, introduce a new parameter, you keep writing one more F test. But in the end, it also boils down to other things as well. It's not just this traceability, how easy it is to find where the problem is with an F test. It's not so easy. And even if you get test failure, you might have to run and debug and understand where exactly is it failing. Because it starts with this and it does end-to-end, executes end-to-end. And that's one of the important factors in deciding whether you use unit tests or an F test to trace and get the feedback. And the test has to be expressive in giving feedback. It's very important for of course, the productivity reasons as well. And then writing, executing, and maintaining effort for an F test is very difficult. As we keep speaking in, especially invoice domain, the closely knit, And we keep breaking a lot of tests whenever we make a check-in. And a lot of the times I hear from developers that they take a lot of time to run, almost overnight. And that sometimes I feel like, okay, let me check in and then see, let me fix if it breaks. But what happens is people keep on checking in, and like a traffic jam, vehicles keep on coming. There is a breakdown vehicle, and then that's everything gets deadlocked. Nobody knows who broke what, and somebody has to sit and really clear the traffic. And that happened in our invoice runs a lot of times when we are collaborating with Taurus, and of course invoice domain with Draco and all. We keep having a lot of stuff, and all of this is because we are using unit F tests in place of unit tests, and the suite keeps growing and growing, and that's not a really productive way to check what's working versus how is it being covered, my functionality. So when you think about whether my this qualifies for an F test or not, think about what am I testing? What feature am I testing? Is that feature, is the test existing for that feature already? Then update the test, improve the test to have that whatever that you have introduced, and let your unit tests take care of the actual low-level behavior of the component. So just moving on. So what's the redemption? How can we get rid of it? This is where I want to talk about enforcements. Of course, we talked about void methods. Avoid void methods. That's always have when you see a void method, think about it. It should either like mutate something or do some side effect like writing to DB or something. Apart from that, if you call a void method, it shouldn't like unless it does something sneaky, which is something you can't test, something like writing to database. Nothing should stay in a void method, because void method is something where I don't know what happens. It doesn't return me anything, so I don't know. I can't assert its behavior. Always strive to write methods that return something. Let me also show with an example. But also, this is another factor which I'll show one example, which is talking about both. And we also see a lot of static methods, and they're both ways. Like some people just feel static methods are bad for unit testing. Honestly speaking, static methods are the best for unit testing, but they have to remain static. Static is the word, like static means that it's boring, right? No matter how many times you call it, it should return you the same result. So this brings me to talk about pure versus impure. So there are two types of functions. This is just terminology, but impure represents all the side effects, like when you're writing to DB, events, etc. And pure logic is like mathematics, where you just data in, data out. You give A and B, and you get A plus B. And it's differentially transparent, which means like no matter how many times you call it, the result doesn't change. So it's important that we keep this separate, not mix it. In that way, like take an example. This is impure, very simple, very naive example. This is difficult to test. It's simple method. I'm interested in the result of A plus B, but it doesn't give me back that result, and it prints that directly to the console. And if I have to test this, then I might have to use mockit or PowerMockit or whatever, and then mock this println. I don't know what I can do, and it's very difficult to test. And you can think of the system println as some DB calls or REST calls that we do in our logic, where we do some computation and directly do some stuff without returning, and it's a void method. This instead is a pure method. You get a result back, and you can either print it to the console, write it to the file, whatever you can do, and you really don't need to test that. Maybe you need to test, but you need an F test to test it, not a unit test. So unit test is especially for testing is A plus B. If you want to test writing to a file, write an F test. Right. So that's how you should think about, and how you should actually separate out pure from impure. But there are places where you can't. But you can migrate impure functions to pure functions like this. For example, again, the same example, if I take this as a parameter, this is how I can call that in prod. So, and while testing, I really don't care that it should print to, I only care about the result, right? This is how I can test it. I would pass a lambda wherein I'm asserting the result. So that's how you can even convert some of where you can't really get rid of this void thing, or they're too much mixed. Like every line you're doing a side effect, something like that. And this is one way. And there's a billing mapper util, which you can also refer, where we followed that. So you should be able to see tests for these methods where previously it had a lot of side effect, what you call something that have shown similar to that system println, but we have extracted out the algorithm part, or the part which just takes care of writing data, or computing, transforming data. And you can easily test methods like this. Because of lack of time, I can't go into details, but I would highly recommend you to just check it out. And I have provided Portage link as well in the deck, which I'm going to share. And all the code I'm discussing, I'm going to share all the resources. So if you can't follow right away in the talk, you can as well ping me or go through it offline. Then moving on, the next factor I discussed with bad design. So I'm just going to show some mock code I wrote for some external talk I had. So think about this simple function, wherein you don't have to care about what it does. All it does is it's a Pokemon collector. So it does a network call, gets Pokemons, and then it has some Pokemons in the DB. It fetches them and then compares if there are any common Pokemons. It discards and inserts new Pokemon. So that's all it does. But what I'm trying to highlight here is this function is directly calling these DB util. So this is after implementation. This is before implementation. So if you see that, so for fetching, it has something called HTTP util. For DB querying, etc., it has something called DB util. So a function like this, it's so I hope you got clarity. I'm not going in details, but like I'll share this GitHub link as well that you can check it out. But what I'm trying to highlight is code like this is not object-oriented programming. Instead, it's procedure-oriented programming. That's a procedure, right? It doesn't have any dependencies injected. All it's trying to do is 1, 2, 3, 4, and then it's directly making calls. And obviously, procedures are not testable. So what you have to do is, what happens, exactly the same thing happens in our domain logic as well, as we make direct calls, our db.load, etc., that we directly do because they have static methods exposed. That leads to, again, the same problem where we can't test them, and we of course need invasive tools like Power Mockito and etc. So thing is, you have to design for tests. So because unit test is your first client for your component, it's like your dog food customer. And if unit test is finding it difficult to integrate or interact or call your component, sure, any other component which is integrating with it will find the same difficulty. And that's how you can measure how extensible your component is, how easy it is to unit test. That's the parameter that speaks about it. So always have a testable design. This is also called test-driven design, test-driven development, a lot of other names. But in the end, the tests are going to give you immediate feedback on how your component looks like. Sometimes even you might have heard this test-driven design. People write tests first and then develop code. So people even go to that extreme. I personally don't do that, but I also feel once you write your component, try to write a test, you'll try to think in a perspective where somebody who is interacting with the component would feel like, and then you will maybe have correct your API or correct your functions, methods, etc., inputs and the parameters and the methods. And always test in isolations. What I mean by that is you should mock your dependencies and not statements. All the when-then things that you find in your code are mocking statements, and that would actually strap your production code. You can't move that line of code once you sort of pin that with a when-then statement in your test. So instead, mock your dependencies on which your component is dependent on. So that way you can test your component's behavior in isolation without actually testing the external thing, as Sachin was talking before. So, and to do that, the thing that we have is dependency injection, which is a very popular pattern, which you should inject your dependencies. And the test that I was showing you before, again, the same thing that I presented in the hackathon. This is how the test becomes, because the component has the injection. So I'm able to inject these things. So in prod, I would have some, and in test, I will be able to inject fakes, which I'm going to talk about more. So as long as you, so this is another method where Soumya was asking about having a parameter in every method is too much, right? So you can have a class level injection as well, injecting multiple components that your component depend on, so that you can test your behavior in isolation. Only the thing that happens in the test can be tested. And you can even tinker these mobs of fakes in a way to simulate your failures or whatever in your tests. And this is a very nice example. We have a complex a complex component called inverse chunk tax processor. Maybe folks from Delphinus and even Taurus can relate. It's one of the complex pieces in entire inverse chunk. And this was tested without a single, without power mop or a single when then statement, only because we were able to inject all the dependencies properly. And we were able to just play around with these dependencies in the test. I highly recommend checking out this, and also pass your feedback if you have any feedback about this testing of these. This is an inverse chunk processor test, and these are some the tests might not like as I'm presenting in the slide, but as you see, these are pretty transparent, readable, and understandable right away. And there is no when-then statement anywhere. And even this code, this is all the injection, and it's more readable from my perspective. Again, it could be personal, but looking at what I sort of learned over the years, people find it more readable because I'm declaring my dependencies. And I know what is even the logger. I have declared that as a dependency, because this is also a side effect. When I'm logging, I'm writing to a file or some other place which is not a part of my particular component. So as long as you sort of declare this explicitly in a constructor, it becomes easy for anybody looking at this component to understand what's happening, what this component is wired with. Like, for example, if you have a car engine, you have multiple ports, right, by which you understand where to plug what. So similar to that. The next problem, of course, legacy code dependencies, which we can't get away with. At entire Salesforce core has it. Like I was saying the other day, this entity object, it was written in 2007 in release 130. I think I just finished my intermediate back then. So that told other classes, some of the classes that we are interacting even today. And the saying goes that if you interact with a legacy component, your code component instantly turns legacy, because you have to really maybe write code in a way that you might have to call that directly, and your code instantly becomes non-testable or legacy, so that you also have the same problems. But how do you get away with that? So there is a catch. If you interact with directly, yes, but what if you can interact with it indirectly? So that brings me to this ports and adapters architecture, wherein a port is just an interface and adapter is an implementation of it. So how does it add a level of indirection? You should be able to inject prod adapters, as I was showing you here. In here, let's say even this component follows the same. All of these, the qualifiers that you see, these are all prod beans. But while I test this, I should be able to inject fake beans. So I have my own fake beans here. So all of these are like, they are neither no-op, where I'm not really interested about this dependency in my test, so I will make it a dummy. And maybe I'm just interested in one of the dependencies to throw an exception. So I would maybe, I have something called, maybe in a different class, iterator test. Here is something, I just wanted to see what happens, how my component behaves if something throws an exception. So I would just make that particular component throw an exception and then inject that inside this and then see how that behaves. So something like that. You can tinker around and get sort of just do permutations, combinations of your side effects and work on it, and without, of course, needing any, as you could see, there is no mocking of statements in this test or the previous test that I've shown. And these two are complex pieces, one of the complex pieces in inverse chunk. They have an algorithm as well, like there's a commit counter, etc. XYZ. Maybe you can watch our VAT session done on tax step to understand the complexity of this. And I'm sure there are other components as well, which are equally complex in our invoice domain as well as payments domain. So if you sort of, what I'm trying to prove is you don't need these fancy form of libraries or when-then statements. You can mock your dependencies and test them 100%. And let me tell you, these tests, we never had to update them. They fail for right reason even today. If somebody really diverges from the behavior, only then they fail. And it's very easy to fix them. When we see a test failure on this, like it's okay, it's very easy because I know where it's failing. I know what needs to be fixed. And we never had a complaint by any developer from our team about these tests where it's difficult to maintain or I don't know what's happening. These tests give us pinpoint feedback on what's wrong and what needs to be fixed, what needs to be corrected. So this is what I have presented in hackathon, where you have a prod adapter, you have a fake adapter. Prod adapter does speak with UD layer, and fake adapter does stuff. This is all about what Loki offers. So it's difficult for you, especially in. Let me go to this. Okay. So you have these adapters. So let us say this DB operator Loki. So it's too much of boilerplate code to actually make everything an interface, a bean and everything. I totally agree that part. And that's where we are solving a problem by introducing Loki. And Loki has a lot of adapters which are out of the box, and they would do common operations which are common to code. Let us say, take this example. This provides methods that do a DB commit, DB rollback, etc., etc. And you can take one more example like entity object accessor. This is very simple. Name, like this is nothing. All it does is it's just a wrapper over entity object dot put, entity object dot bulk save, DB load. All of these are very familiar to us. It's just that instead of directly interacting with them, we are wrapping them over this thing. And the advantage I get is I can also ship a out of the box fake, which this is overload. Where is this fake? Let me go to this fake library, entity object accessor fake. So this is the fake layer. So you can see, I'll also talk about what these are. But what I'm trying to say is I can ship a fake thing which you can directly inject in your tests and use them without any extra boilerplate code. So plug and play adapters for you and with zero learning curve, because as you understand Spring, auto wiring is all you need to do. And there's more innovations coming, which I'm going to speak. I think I'm just going ahead of slides, ahead of my script. But then this is Loki for you. And Loki, it started in 236, yeah. It incubated in our tax step. We were just experimenting. And it was carefully brewed like 236, 238. And from Delphinus, we took feedback. We sort of understood how other developers are feeling about using it. And we published, of course, in Hackathon. This was a runner-up. And then in 240, of course, people naturally are gravitating towards using this because nobody can force you to do something, because if there is a lot of learning curve, there's a lot of impedance, you obviously sort of try to get away from using this. But obviously, because we have a lot of advantage on top of it, people are gravitating. And now we are also going to other teams trying to get more feedback and improve this toolkit more and more. And that layer, so this is one thing, the concept that Loki tries to promote. Firstly, Loki, to use Loki, you have to, of course, use proper dependency injection. It's not like it lets you test even if your design is bad. So there is some refactoring effort needed, but that said, refactoring is not too much. It's not like you have to change a lot of things. You just need to identify your dependencies and put them in a constructor, similar to the one I've shown. And once you've done that, you should be able to do a black box unit testing. What I mean by that, unit testing is not testing internals. Or yes, of course, you're testing your low-level components, but that said, you still should treat that unit as a black box. If you are testing the internals by doing all this, then of course, as we mentioned, it's trapping the code, and it's like A2E tests for your component. Priyanka is dropping off, I guess. Okay, cool. Yeah, Priyanka. Thank you so much.
Thank you, guys.
Yeah. So I'll show one more test tax request builder. This is something that's recently written. So tax, I'll also, before that, I'll have to explain the funda of it. So this is one thing when using PowerMock, you would see statements like white box dot set internal state. This even lets you override private fields or final fields, etc. And you'd see statements like this when this is then return this. You actually don't care about that whatever that is in the statement. It's like a dummy data, but still we sort of write in our F test, and a lot of do, then, when, nothing, all this. So Loki wants to remove all this noise out of the test and lets you focus on testing the behavior. So let's take this example of this test. So take, for example, you have two parameters, list of invoice lines, and which has two fields, shipping address ID, billing address ID. And you also have a map where there's address ID to address group. Group is something as an object which holds all the address data. You pass these two things to a function, and the function's behavior or responsibility is to get this shipping address ID and find the relevant address group and populate that into its ship to bill to properties of this line item request. In the end, I get list of line item things. So that's a sort of just a brief of what the component does. But if you see the production implementation, this is the request builder. So the thing is, to test that one behavior of this component, you need to go through or pass a lot of things. I'm just taking an example of a credit tax request builder test. I wanted to write a before after for this test, but I couldn't find time. So I'm just taking this example of what it takes to test a component like this. Credit tax request builder is synonymous to tax request builder. But what you might need to write is a lot of setup code, lot of random data, and every when statement. None of these are auto-generated, right? We as developers know to write a thing like this, we really need to go scrutinize, understand the broad code, and then be very specific on what I need to when then. And then this, to write, it takes a lot of time. To maintain, it takes a lot of time. And even if with all the efforts, it doesn't aid your refactoring. So to a similar test using Loki would look like this. So you don't see a single when statement, and you are focusing on your behavior as if you're trying to, what I'm trying to do is in the given part, I'm trying to prepare the invoice lines that I've shown. I'm trying to prepare this, this and this. So here, and the when is I'm calling my component, and this is just a way I'm extracting out the result I've got, and just to extract the property that I'm interested on. And this is I'm asserting it. That's it. Nothing else. How is it possible? How is it possible? I actually wanted to go into details due to lack of time, but I'll still try. But if it's fast, please feel free to reach me out. I'll give you in-depth information. Loki has something called a dud layer. So what a dud layer is there's a combination of different data structures which are interconnected, and then they simulate a real DB. So what happens when I do a entity object fake.getString is it generates a mock shipping address or random shipping address for me in the backend, and then of course it fills out this field. Same with other things. So my ID to address group is filled with random data. But the next question comes, okay, now I don't know the random data. How am I supposed to assert? You actually don't need to assert on that particular random data if you rely on your taking your mocks properly. So what happens is, let me go inside this component, tax request builder. So this is a function where it happens. Again, I'm just rushing it, but you can go. This is in prod. You can check it out right away in your code base. This is where this field, address field is here, and yeah, this is where identity object.getString. I'm getting the string out of here and populating the address group from invoice line ID, and then I'm using again entity object accessor to get street, populate street, city, identity, everything. Now that I'm this synchrony is there between entity object accessor and entity object fake. This doesn't sort of behave differently. It behaves as if there is a real DB, and you're now able to just test, and all this get and everything, they're all in sync. They would give you back same mock data. You can even debug this test and see. So what I'm trying to say is, in the end, if the behavior of the component, if you can refactor this component in any way without changing the behavior, this test holds good. This test doesn't break. And in the end, it's so easy to write as well. Like while I was writing, I wanted to remove myself from understanding what the tax request builder is. Because if I really think I need to just check it out. If you have to reach this line of code, you need to pass multiple lines, multiple getters. And it's impossible. It takes a lot of time to write a lot of when then. But in here, I don't care. It's a black box for me. I write what I think it should behave. I give you the mock data and receive the data back, and I assert on what I think it should do, and that's what I do. So that's how it can ease your unit tests, and I can take a lot of examples from invoice run as well. This is one of the recent examples, and we have extensively used this invoice run. And this is another example that I presented in Hackathon that you can check in my demo video, which I'm going to also share the link, which also talks about how this in-memory layer works in another example. And because of all this, like Loki gives you a lot of perks, like it enables unit testing, domain-driven logic boosts unit testing, transparent and declarative, which is very important for me as it gives proper feedback on what fails, and it enforces appropriate DI and promotes clean code. And there's a list of adapters that we currently have out of the box from Loki, and we keep on trying to grow it, improve it. As Manoj was rightly saying, maybe we might reach out to him to have that mock MQ in this collection of things so that it can benefit across core, across any module which is consuming this. So that's the idea. We only allow things that are common, not specific things go into the specific module itself. You can again check out batch invoice run config, where there are so many examples. There's a mix of specific adapters versus Loki adapters, and the impact. Same, we have used it in multiple and 236 to up to 240, and we achieved organic test unit test coverage that we can trust. So, and cost saving, this is a random thing, but yeah, overall, it's difficult to measure at the same time. But folks, as they keep using, are feeling much better, feeling a lot more productive in writing unit tests. And these are all the references, resources that talk about testing and other things that I have referred. And finally, yeah, this is a famous quote. Can anyone guess who said this?
Good one.
It's the bus conductor. So let's now read it, the quote. You will get a different meaning. So yeah, but honestly, we want to be the change that we want to see. So yeah, let's be the change. Let's try to bring that change, and let's. Again, in the end, it's not something that we have started that, but we want to take feedback and go take directions in a way that helps everybody. So feel free to pass us feedback, feel free to discuss, ask more questions, and thanks a lot.